In this section we're going to talk about circles, tangents, and we're going to learn some new vocab. So look at the circle with center O, and I want to point out that the way you will find this written is this is a circle, center O. So the center is actually written after the circle symbol. In a circle you have a radius that extends from the center to the circumference. In fact, the definition of a circle is that it's a set of points in a plane that are equidistant from a given point. So if you look at these two blue segments, they are actually equidistant from the center, and they are called the radii. So radius. A radius is half the length of a diameter. So if I draw another radius which is collinear with that radius, I get a diameter. Okay, let's call this A, B. So the diameter is segment AB, the radius is segment OA, and a chord is a segment that intersects a circle in 2 points. So if I draw this, I don't know where I lost my segment, so let me reclaim that back. Here we go. This segment intersects the circle in points C and D, so segment CD is a chord. Segment AB is also a chord because it intersects the circle in points A and B, and it is actually the longest chord in a circle. Some more vocab: a secant and a tangent. A line or a segment or a ray that intersects the circle in 2 points is called a secant. The important thing is that if it is a segment, its endpoints are not on the circumference, they extend outside the circle. A tangent is a line or a ray or a segment that intersects the circle in 1 point only. So this is a tangent, and this is a secant. So secant is line AB, and at this point our line for the tangent doesn't have a name, but it intersects the circle at point D. When you have coplanar circles, you can have one of the following situation. You can have 2 points of intersection. Oops, I didn't mean that. I didn't mean that. Okay, we can have 2 points of intersection, or one point of intersection. For the one point of intersection, we say the circles are tangent circles, but the circles can be tangent to each other either inside or outside. And I think the diagram explains it. When there are no points of intersection, you have two different situations. You either have concentric circles, so this is situation 1 and this is situation 2. In situation 1, the circles don't touch at all. They're not within each other. And in situation 2, concentric circles are circles with the same center but different radii. What are common tangents? Common tangents are a line, ray, or segment that is tangent to two coplanars. So that's the key here, to two coplanar circles. A common internal tangent intersects the segment that joins the centers of two circles. So when you join two circles with the segment, if your tangent intersects that segment connecting the two centers, then it's internal, otherwise it is external. So what you can do is test yourself with the following diagram and see if you can determine whether the tangent is internal or external, and then the answer is given to you as well. Theorem. In a plane, a line is tangent to a circle if and only if, there's an if missing here, so let's, if and only if the line is perpendicular to a radius of the circle at its end point on the circle. So take a look at this diagram here. This is your tangent line, lowercase m, and this is your radius, and we're saying the only way we will consider or determine that m is a tangent if the radius makes a right angle with the tangent at the point of intersection on the circle. Tangent segments from a common external point are congruent. So here we go. These two segments are congruent. So if you were given the length of RS to be 10, you would conclude that SD is also 10. If you're given algebraic expressions, just set them equal to each other. So here are some problems that will test your knowledge base, and you have answers at the end. So good luck.